When installing recessed can lighting, it's important to understand how to calculate the correct amperage. The 125% rule does not apply to recessed cans. Instead, you should use the specified amperage rating per can. In the provided scenario, it is 1.5 amps per can. The 125% rule applies to branch circuits, which are the wires that supply power to the recessed cans. A branch circuit can handle up to 125% of its rated amperage for a short period of time. However, recessed cans are not branch circuits. They are individual devices that have their own amperage ratings. If you exceed the amperage rating of a recessed can, it can overheat and cause a fire. Therefore, it is crucial to adhere to the specified amperage, in this case, 1.5 amps per can, regardless of the wattage rating of the can. Think of it this way: the branch circuit is like a highway. It can handle a temporary surge of cars or amps. The recessed can is like a bridge with a set weight limit or amperage rating. Exceeding that weight limit or amperage rating leads to potential problems. Firstly, consider the voltage of the circuit you are working with. In North America, common voltages are 120 volts and 277 volts. Secondly, check the amperage rating of your circuit breaker. For example, a 15 amp circuit breaker can handle a certain number of recessed cans, and a 20 amp circuit breaker can handle a different number of cans. This calculation is based on the 1.5 amps per can rule, not the 125% rule. Thirdly, consult the National Electrical Code, or NEC. The NEC provides guidelines and regulations for electrical installations to ensure safety. The NEC is a comprehensive document that outlines best practices for electrical work. Familiarize yourself with the relevant sections of the NEC for recessed lighting installations. This ensures you are following code and prioritizing safety. Fourthly, choose the appropriate wire gauge for your circuit. The wire gauge must be suitable for the amperage of the circuit and the length of the run. Undersized wires can overheat and cause a fire hazard. Use a wire size calculator to determine the correct wire gauge for your specific installation. This calculation depends on the amperage and the distance to the load. Fifthly, properly ground all recessed cans. Grounding provides a path for fault current to flow, which helps to prevent electrical shock. Ensure that all grounding connections are secure and compliant with local electrical codes. This is a critical safety measure to protect against electrical hazards. Sixthly, use the correct type of junction boxes for your recessed can installations. Junction boxes protect wiring connections and prevent accidental contact with live wires. Choose junction boxes that are rated for the environment in which they will be installed, such as damp or wet locations. Seventhly, install thermal insulation around the recessed cans if necessary. Thermal insulation helps to prevent heat loss and improve energy efficiency. However, it is important to use insulation that is rated for use around recessed lighting fixtures. Avoid using flammable materials that could pose a fire hazard. Eighthly, consider using LED recessed cans. LED recessed cans are more energy efficient and have a longer lifespan than traditional incandescent recessed cans. They also produce less heat, which reduces the risk of overheating. LED recessed cans are a great option for saving energy and reducing maintenance costs. Ninthly, inspect your work carefully before energizing the circuit. Check all wiring connections, grounding connections, and insulation to ensure that everything is installed correctly and safely. A thorough inspection can help to identify and correct any potential problems before they cause a hazard. Tenthly, use a multimeter to test the voltage and amperage of the circuit. A multimeter is a valuable tool for troubleshooting electrical problems and verifying that the circuit is operating within its specified parameters. Use a multimeter to measure the voltage of the recessed cans and the amperage draw of each can. These measurements can help you identify any potential issues such as voltage drops or excessive current draw. Let's delve deeper into the technical aspects. Firstly, let's talk about the calculation itself. If you have a 15 amp circuit breaker at 120 volts, you would divide 15 amps by 1.5 amps per can. The answer is 10 cans. That means a 15 amp circuit breaker can accommodate a maximum of 10 75-watt recessed cans if they each draw 1.5 amps. Secondly, consider the voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning. Excessive voltage drop can cause lights to dim, motors to run slower, and other electrical equipment to malfunction. To minimize voltage drop, use the correct wire gauge and keep the circuit length as short as possible. Thirdly, understand the difference between series and parallel circuits. In a series circuit, all components are connected in a single path. If one component fails, the entire circuit will be interrupted. In a parallel circuit, each component is connected to the power source independently. If one component fails, the other components will continue to operate. Recessed cans are typically wired in parallel. Fourthly, be aware of the potential for harmonic distortion. Harmonic distortion is a phenomenon that can occur in electrical systems due to nonlinear loads such as electronic ballasts and LED drivers. Harmonic distortion can cause overheating of transformers, neutral conductors, and other electrical equipment. To mitigate harmonic distortion, use filters or other mitigation techniques. Fifthly, consider the ambient temperature. The ambient temperature is the temperature of the air surrounding the electrical equipment. High ambient temperatures can cause electrical equipment to overheat and fail. To prevent overheating, ensure that electrical equipment is properly ventilated and that the ambient temperature is within the manufacturer's specifications. Sixthly, understand the concept of power factor. Power factor is a measure of how efficiently electrical power is being used. A power factor of 1 indicates that all of the electrical power is being used to do work. A power factor of less than 1 indicates that some of the electrical power is being wasted. To improve power factor, use power factor correction capacitors. Seventhly, be familiar with the different types of electrical enclosures. Electrical enclosures protect electrical equipment from the environment and prevent accidental contact with live wires. Choose enclosures that are rated for the environment in which they will be installed. Eighthly, understand the principles of electrical safety. Electrical safety is paramount when working with electricity. Always to energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment. Never work on electrical equipment when you are wet or standing in water. Ninthly, be aware of the potential for arc flash. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash can cause severe burns, blindness, and even death. To protect against arc flash, wear appropriate arc-rated clothing and use specialized tools and equipment. Tenthly, consider the impact of your electrical installation on the environment. Use energy-efficient lighting and equipment to reduce your carbon footprint. Dispose of electrical waste properly to prevent pollution. Let's explore some advanced considerations. Firstly, delving into the specifics of NEC Article 410.16 addresses recessed lighting and its installation requirements. Understanding these specific requirements is crucial for compliance and safety. Secondly, exploring the impact of insulation contact, also known as IC rating, of recessed fixtures is important. IC-rated fixtures are designed to be in direct contact with insulation, reducing the risk of fire hazards. Non-IC rated fixtures require specific clearances from insulation. Thirdly, let's consider the use of low-voltage recessed lighting systems. These systems often utilize transformers to step down the voltage, offering energy savings and design flexibility. Understanding transformer sizing and wiring requirements is essential for these systems. Fourthly, investigating the use of smart home technology with recessed lighting can be done. Smart home systems allow for dimming, color control, and scheduling, enhancing energy efficiency and ambience. Integrating these systems requires knowledge of wiring and programming. Fifthly, let's dive deeper into emergency lighting considerations with recessed cans. In commercial buildings, emergency lighting is crucial for safety during power outages. Recessed cans can be integrated with the emergency power systems. Sixthly, think about the importance of proper ventilation for recessed lighting. Heat buildup can reduce the lifespan of the fixture and pose a fire risk. Proper ventilation ensures that heat is dissipated effectively. Seventhly, investigate the use of lighting control systems. These systems can optimize energy usage and provide customized lighting scenes. Integrating these systems requires knowledge of control wiring and programming. Eighthly, understand the importance of regular maintenance for recessed lighting systems. Regular maintenance includes cleaning, bulb replacement, and inspection of wiring connections. Proper maintenance ensures the longevity and safety of the system. Ninthly, let's consider the impact of recessed lighting on the overall building design. Recessed lighting can be used to create different moods and highlight architectural features. Planning the lighting design early in the project can enhance the aesthetic appeal of the space. Tenthly, explore the latest trends in recessed lighting technology. New technologies such as OLED lighting and wireless control systems are constantly emerging. Staying up to date on the latest trends can help you create innovative and energy-efficient lighting solutions. Now let's dive into practical examples. Let's say you are installing recessed lighting in a kitchen with a 20 amp circuit. You need to calculate how many 75-watt recessed cans you can safely install on that circuit. Using the 1.5 amps per can rule, you can divide the circuit amperage 20 amps by the amperage per can 1.5 amp. This gives you a maximum of 13.33 cans. Since you cannot install a fraction of a can, you would round down to 13 cans. Therefore, you can safely install 13 recessed cans on a 20 amp circuit. Let's consider another example. You are installing recessed lighting in a basement with a 15 amp circuit. You want to use LED recessed cans that draw only 0.5 amps each. How many cans can you install? You would divide the circuit amperage 15 amps by the amperage per can 0.5 amps. This gives you a maximum of 30 cans. Therefore, you can safely install 30 LED recessed cans on a 15 amp circuit. Let's consider a more complex example. You are installing recessed lighting in a commercial building with a 277 volt circuit. The recessed cans draw 0.3 amps each. The circuit breaker is rated at 20 amps. How many cans can you install? You would divide the circuit amperage 20 amps by the amperage per can 0.3 amps. This gives you a maximum of 66.67 cans. Since you cannot install a fraction of a can, you would round down to 66 cans. Therefore, you can safely install 66 recessed cans on a 20 amp 277 volt circuit. Remember that these calculations are based on the specific amperage rating of the recessed cans and the amperage rating of the circuit breaker. Always consult the manufacturer's specifications and local electrical codes to ensure that your installation is safe and compliant. Also remember not to use the 125% rule for the individual can. It only applies to the main branch circuit. This information is for educational purposes only. Always consult with a qualified electrician for any electrical work.